Okay, everybody, I told you I'd try to do the last 4 homework problems that I didn't have videos for yet. So you're going to have to look in your book and read the problem because they're word problems and they're a little too long for me to write the whole thing, but I will try my best to give you information so that you can kind of see where I'm coming from with this problem. So problem 105, it says this. The cash flow per share for Timberland Company was 18 cents. Let me go ahead and write that down. 18 cents in 1995, and then it was $3.65 in 2000. And they want me to write a linear equation that gives the cash flow per share in terms of the year. They want me to use t equals 0 for 1995, and we talked in class today about why it would be important to go ahead and switch that to t equals 0 for 1995. 1, because once I write the point as 0.18, I now have my y-intercept. That's an 8. I have my y-intercept, so that makes it a little bit easier. Also, Timberland wasn't around for hundreds of years, so there's no need to start to write 1995 and then 18 cents. And then year 2000 would be year 5. So after 5 years, it was at 365, and at year 0, it's starting, it was 18 cents. So your y-intercept here is 18 cents. So that's going to be important, and then we'll find the slope here in a second. They also want me to predict the cash flow per share for 2005, which would be when t is 10. If t is 0 is 95, then 2005 would be when t is 10. And then again in 2010, which would be when t is 15, or x, or whatever you want to use. All right, so I know the y-intercept is 18 cents. Now I'm going to find the slope. So that is y2 minus y1 over x2 minus x1. So that is 365 minus 18 cents. That's 347 divided by 5. And I get 0.694. So that, if I were to ask you what does the slope mean in context of this problem, it means that the cash flow is going up 69 and a half, or around 69 cents per year, and starting at 18 cents. All right, so my equation, my line is going to be y equals 0.694, I guess I can put t, or x, plus 0.18. Because 0.18 is my y-intercept. So if they want me to find it in year 2005, I'm going to do 0.694 times 10 plus 0.18. I'll do that in a second. And then again for 2010 would be 0.694 times 15 plus 0.18. All right, so 0.694, let me do it on my calculator I've got here, times 10 plus 0.18, I get $7.12 for 2005. 7.12, then 0.694 times 15 plus 0.18, I get 10.59. Whoops, 10.59 for 2010 if the data continues to follow this trend or this model. All right, problem 110. Problem 110 says a school district purchases a high volume printer, copier, and scanner for $25,000. That's how much they purchased it for. After 10 years, the equipment will have to be replaced. Its value at that time is expected to be $2,000. So after 10 years, it's $2,000. So in year 0, when they buy it, in year 0, not year 1, in year 0, when they buy it, it's $25,000. So it loses money every year, and after 10 years, it's at $2,000. Write a linear equation given the value V of the equipment during the 10 years it will be in use. So all I need here, because I have the y-intercept, 25,000. Anytime it's 0 something, that's your y-intercept. So B is 25,000. That's my starting amount. And then all I need is M. So that's going to be 2,000 minus 25,000 over 25,000, not 2,500, over 10 minus 0, negative 23,000 over 10 is negative 2,300. That's your slope. That's how much it's losing in value per year. It's an expensive copier, so you got to think that that's how much. That's okay, because it's going from 25,000 to 2,000. So the equation is y equals, and they wanted me to use v instead of y. So v, the value equals negative 2,300. I'm going to use t for years. You could use x and y. It's the same thing. Negative 2,300 is a slope plus 25,000 for my y-intercept. They asked me to use v, so I used v and t instead of x and y. So if I plug in the years into this equation, I can get the value of that printer. And they don't ask me to predict anything in that one. All right, 115. Let me pause it for just a second. All right, so in number 115, we've got a garden that's 15 meters by 10 meters. So I'll put 15 meters over here and 10 meters. Then we got a walkway all around this garden that is has a width of x. Okay. They want me to write the, that's the diagram for part A. B says write the equation for the, that's A, sorry. B says write an equation for the perimeter. Remember, the perimeter is 2 times the length plus 2 times the width. So the perimeter in this case, this length here, if from here to here is 15, and I've got an x, I've got a width of a walkway over here and one over here. So this length is going to be 15 plus 2x. 15 for the middle part and then an x on each side. So 15 plus 2x times the width would be, it's 10 from here to here, and then I've got an x. So it would be 10 plus 2x. 10 plus 2x. Doesn't look like a 10. 10 plus 2x. That's the perimeter. C says use a graphing utility to graph the equation for the perimeter. All right, let's see if I can pull up a graphing utility right now. So 15 plus 2x times 10 plus 2x in my y equals 15 plus 2x and 10 plus 2x. And perimeter, if there wasn't a walkway at all, the perimeter would be 50. So let's say I go something like, I couldn't have x be a negative number. Let's do that for, let's go from 0 to 10 on my x's, and from, let's go from 50 to, I don't know, 150 maybe? It might be too much on my y's. You can adjust it if it doesn't look like anything that would turn out, which mine doesn't look like it's showing up here. Well, let me look. Oh, it started at 150. I'm not even thinking 150. X is 0, 10, and 15. Did I do something wrong over here? 15, 30. Oh, I put times instead of plus. Y'all should have helped me catch that. 2 times the length plus 2 times the width. And I did the area. Okay, let me do this again. How about doing 2 times this, 2 times 15 plus 2x. I wrote it right on that other page and then tried to remember when I came over here, and that didn't work. Plus 2 times 10 plus 2x. Okay, that should work better. I was wondering why it wasn't showing up. 2 times the length plus 2 times the width. And then I'm going to graph that. All right, and it is linear. So now I need to find the slope of that line. And there's a couple of ways I can do that. If I were to actually, see I put area over here too. That's not perimeter. 2 times the length plus 2 times the width. Okay. So if I were to work that out, because that might be the easiest way, I'd get 30 plus 4x plus 20 plus 4x which would be 50 plus 8x. What's the slope of that line? It would be 8. And part C says graph it and determine the slope of the graph. So the slope is 8. This is part D. Determine the slope. C is looking over here at this. This is part C, the graph. Just taking a look at it, which I can't write a C. That's C. And then D says find the slope. And so we did. The slope is 8. And it says for each additional 1 meter increase in the width, determine the increase in its perimeter. So the increase in perimeter is 8. So for each 1 meter increase in width, there is an 8 meter increase in perimeter. And let's look at that. If x is 1, then I'm going to have to add 1 here. See, I'd have to add 2 here, 2 on this corner, 2 on this corner, and 2 on this corner. So every time you add another feet, you're adding it in really 8 places, because you'd have to do it here and here, here and here, here and here, here and here. So there's 8 places you'd end up having to increase that perimeter. And that's why every time the width of the walkway goes up by 1, the perimeter would go up by 8. And problem number 120, last one, is an instructor gives some regular 20-point quizzes and 100-point exams, and they give you the points. They're 1887. I'm going to show you how to do this one on the calculator. 1055, 1996, 1679, 1376, and 1582. We're going to do all of this on the calculator. Okay, so let me show you how to do that. Go to your calculator. I'm going to clear out what's in the y equals right now because I don't need that. Push stat and then push enter. And you should have some lists that come up. So in L1, I'm going to put all the x's. 18, 10, 19, 16, 13, and 15. And then in L2, I'm going to put the y's. For 18, it was 87. For 10, it was 55. For 19, it was 96. 16, it was 79. 13, 76. And 15, 82. So now I have that. So part A says sketch a scatter plot. So what you want to do is to do a scatter plot on your calculator. If you'll look right here above the y equals, it says stat plot. So if you'll go to second y equals, right now all of my plots are turned off. So I want the scatter plot to be turned on. So if you'll hit enter and turn it on. Right now this type is a scatter plot. My X list is in L1, my Y list is in L2. It's going to mark these marks. It really doesn't matter what kind of mark you have. It's going to do that in blue color. If I hit graph right now, I'm probably not going to see it because of my window. So what I'm going to do is I'm going to hit zoom. And I'll go zoom 9. It's called zoom stat. That fits your window to the data that you have in your list. So that way you don't have to come over here and do your window by hand. I'm just going to hit zoom 9. And that's what my scatter plot looks like. Now, if I hit window now, see how my window changed? I had done it from 0 to 10 and I'd done this, but now it's fitting this data the best way it can. So part A says sketch a scatter plot. So here it is. B says use a straight edge to connect the points. C says find an equation for the line. Now, if you did this by hand, you'd pick 2 points, any 2 points. You could do the first and the last one. Find the slope, and then that'd be M, and then use one of the points and find B like we've done. But we're going to just get the calculator to do it for us. So I'm going to push stat. I'm going to go over to calc, calculate, and I want a linear regression, a line. That's number 4. My X list is in L1. My Y list is in L2. I'm going to go ahead to make this a little bit easier and store my regression equation so that I don't have to retype it. So I want to store it in Y1. So I'm going to hit the variables button, vars, go over Y vars. It's a function, and I'm going to choose Y1. So I have my X list in L1, my Y list in L2, and I'm telling it to store the regression equation in Y1. And I want it to calculate that. All right, so the equation of my line would be y equals 3.97x plus 18.9. That'd be the best equation that fits this data for how a person's quiz grade compares to their test grade. And then estimate the average test score for a person with an average quiz score of 17. Well, now that it's in y equals, see, that's already the equation. They typed the whole thing out. I probably would have rounded it off if I had to do it. But they typed the whole thing out. And so you can see this line fits it pretty good. But it also gives me a table. And so then in part D, they said, well, what would it be if if we had X is the quiz grades and Y is the test grade. So what if we had a quiz grade of 17? What would you expect the test grade to be? And if I had a quiz grade of 17, I would expect the test grade to be 86.45. That's part of D. Part E says the instructor adds 4 points to the average test score of everyone in the class. Describe the changes in positions of the plotted point and the change of the equation of the line. Well, all that would do is if they added 4 points to each one, it would just move each of these points up 4 because they added 4 points to the test grade. So all that's going to do is change the y. It's not going to change the x, which is the quiz grade. This line would just be moved up 4, which would be parallel. So what that would do with my equation of the line is that it would keep the slope the same, but instead of this y-intercept being 18.9 something, which I can't see the whole thing, I would want to add 4 to that, and it'd be 22.9 something. And that's how it would change it. All right, that's through problem 120. I'm going to save this and get it on your Google Classroom, and I will see you tomorrow.